All right, guys. This video is going to cover all 3.1, which is just a brief introduction to quantitative variables and scatter plots. So we'll do all of the 3.1s. It's going to be the first and second page, or the front page and the back page of the first. So we're going to look at a couple things. Scatter plots being the big one, correlation being the other. So we'll look at a couple of those things. So yeah, we'll go from there. So first question is, why do we study the relationship between two variables? How is it different than chapter 11? So chapter 11 is chi-square. So chapter 11 is going to be all how do you analyze categorical data versus this right now, which is going to be all quantitative data. So to answer the first question, why do we study the relationship between two variables? For two reasons. To make predictions and to explain some phenomena. Okay, so this is the why. So why do we do this? So like you guys know, I'm a student doing this, studying applied stats. We do this all the time, right? We do a lot of modeling. We want to make predictions. We want to explain why something happened. And it's just used a lot. And then, like I said, this chapter covers quantitative data. For chapter 11 is your chi-square. Looks at the relationship between categorical data. All right, next thing, looking at what's the difference between an explanatory and response variable. So the response variable measures the outcome of some study. An explanatory variable may help explain or help predict changes in a response variable. All right. So another word for explanatory variable sometimes is predictors. Okay. So those words kind of change interchangeable, right? So you have some predictor for some response. How do you know which variable to put on each axis? Explanatory, right? The X stands for x-axis and explanatory. Okay. And then conversely, your response variable goes on the y-axis. A couple of graphing points here. First of all, your graphs do not need to start at 0, 0. Okay. Right? Just because if you're looking at, I don't know, like income, for example, and I don't know, like IQ or something, those are two variables that are going to be fairly large, right? And so starting at 0, 0 is what makes sense. But the one thing you do need is your scales must be consistent. Right? So no matter what you do, just make sure your scales are consistent when you graph. Okay, so now a scatter plot shows the relationship between two quantitative variables measured on the same individual, right? So for example, if you're looking at IQ and income, right, you have both their scores for one person. each individual appears as a point or dot on the plot. Then if you're looking at for only one quantitative variable, you can use a dot plot, histogram, box plot, stem and leaf. So these are all things that we looked at in chapter 2 and chapter 1. Okay. Stem and leaf plot. Okay, so now we're switching from one variable to 2. Okay, how do you lose points on the AP test? Okay, we've talked about this many times. Poor labeling. Okay, no titles. You have to non-equal scales. Your markers are not clear. You have unclear value marks. By markers are not clear, I mean like the points, like the scale on the graph. Layout of the graph. Okay. Basically, your goal is to make the graph as clear as possible. Moving on to the next page. What are 4 characteristics you should consider when describing a scatter plot? So your 4 big ones are going to be number 1, which is direction. And this can take the forms of positive, negative, or random, which is the same thing as no pattern, no direction. Number 2, you have form, which is either going to be linear or nonlinear. Right, linear in this case being a straight line because we're only looking at 2 variables. Nonlinear being some sort of other shape. It's a parabola, square root function, stuff like that. Okay, do not let outliers sway you. Okay. You want to mention them, but stick with your gut reaction. Okay. We're going to look at what happens with graphs when they have outliers and what happens to their regression lines and their correlation. So we'll look at that as well in this chapter. Number 3, you also want to look at the strength. How closely does do the points follow the form? Okay, so when you're describing a graph, and let's say it's a perfect parabola, right? You can mention that in form, right? But then your strength will still be extremely strong. Okay, so your strength is going to match your form. Okay, but now let's say you have like a somewhat of a, I can draw this out. So let's say you have a graph. Oops. Right, so here are your axes. And then we have some dots here that looks somewhat positive, right? If I was going to do a line of best fit, I could do one with this, right? But this is pretty random. Okay, so this is like your graph. Okay, something like this. And you can argue that, okay, well, you could put a line of best fit kind of through here, right? Maybe something like this. Okay, so this could be a linear pattern, right? It doesn't really look like it's a parabola. It doesn't look like it's a square root function. It doesn't look exponential, right? But here your strength would be extremely weak. Okay, so your strength is a measure of your form. So if you have a data set that looks like if you have a data set that looks like a perfect parabola, like I said earlier, okay, then your form will be nonlinear, but then your strength will be extremely strong, right? But if I try to fit a linear model to this, and I try to draw a line, it's like something like this, right? Then obviously that's not as strong. So again, this is why the graphing is so important in chapter 1, because you need to look at the data in order to figure this out. Okay. And then number 4 was any unusual features. This is where the outliers come in. So a couple things you can talk about for outliers, like I just said. Outside the overall pattern. Again, there's no rule required for this. If you just notice something, talk about it. And then any sort of specific clusters, okay? So our data bunched together, okay? So for example, this clustering one is actually pretty important because if I draw another graph real quick, so you have your axes, and then you have one set of data that is like this. And then you have another set of data that looks like, or same set of data, but you have 2 distinct clusters. And the reason why this is important is because what I can notice is that if I look at this cluster here, this looks like it has a positive relationship, right? I could draw a line of best fit somewhat like this, okay? And then if I look at the other one, well, this one kind of looks like it's got a negative relationship. That's got a line of best fit, something like that, right? So what you should notice when you see something like this is that these may be 2 distinct things, right? So that whatever variable we're looking at in this case, right, there may be some factor of this that we could kind of break apart when we analyze it, and then analyze this orange group and this pink group separately, right? Because there's some sort of distinct pattern going on here, right? Where if you were to not look at the data and you were just like, oh, calculator, just have your calculator spit out a line of best fit, it's probably going to do something like this, right? It's probably going to make a parabola. But here we clearly see we have 2 distinct groups. So that's important. Okay. I'm going to skip this and I'll let you guys kind of try it on your own and then we can kind of look at it together in class. Okay. So what is correlation? Correlation is, so the correlation, we denote that with an R, measures the direction and strength of the linear relationship, okay? Correlation is only a measure of linear relationships between 2 quantitative variables. There's an equation. You don't need to know this, but I'll write down just so you have it. R equals 1 over m minus 1 times the summation of each individual x, which is xi, minus the mean divided by the standard deviation times each individual y. So you standardize each one of the values, sum them all up, divide by m minus 1. Okay, so that's the equation. All right, last thing here. What are some properties and characteristics of correlation? Talk about a couple things here. First of all, R has to be between -1 and 1. Okay, that's a good AP stats exam question because I'll give you an R value that's bigger than 1 or smaller than -1, and they'll be like, "What's wrong with this?" Right? It'll be a good multiple choice question just to see if you're reading the problem correctly and closely. So this has no distinction between x and y, which means you can flip, so which means that you can flip the variables, get the same value, because again, you're just standardizing them. Okay, this is a big one. R does not change when the units of measure change. And I want you to think about that. There's a Y. R has no units of measure. Okay, big one here. Correlation, you've heard this in all of your classes. At some point does not equal causation. So one of the things we're going to look at is like a bunch of, on Canvas is going to be looking at a bunch of things that are correlated that just, you know, this doesn't apply causation. So for example, like ice cream sales and child abductions is one of them. The amount of people studying STEM and like suicide is another one that's really funny. So yeah, some definitely some interesting things there. Looking at some interesting correlations. Other things, you need 2 quantitative variables. And then this is the last year, pretty important. R is affected by outliers. Big one. And the other big one is just because R is close to -1 or +1, okay, it does not mean that the relationship is linear, okay? There's actually a really good graph in your textbook about this. It has 4 different graphs, all with the same R value, but are completely different, right? So one's linear, one's like a parabola, one's completely like pretty random. And so it's really interesting to see. So just because you have an R value of like 0.9 doesn't mean your data is linear necessarily. Okay. So that's the end of this video. And I'll see you guys in the next one.